Microorganisms like bacteria, fungi, amoebas or tiny algae can be found almost everywhere on our planet. These unicellular organisms form a microverse, which is vital to our survival. They not only ensure a functioning ecosystem, they also provide us with a functioning immune system and metabolism. Interfering with this fragile system can unbalance it. The consequences are devastated ecosystems, crop failures, and life-threatening infectious diseases. The goal of the scientists in Jena is to understand the balance and disbalance of this complex microverse and have a positive, targeted impact on it.
We would like to understand the interaction of microorganisms at the molecular level and how they keep in balance in the whole ecosystems. Prospectively, if we understand the processes involved, we will be able to develop entirely novel therapies for human diseases and new technologies for sustainable agriculture and for cleaning the environment.
The infection biology, chemical and biogeochemical processes of microorganisms are already being investigated in 4 collaborative research centers in Jena. Young researchers from all over the world are also studying the communication of microorganisms at the Excellence Graduate School Jena School for Microbial Communication. Based on this extensive expertise, a new interdisciplinary cluster is being created.
The Microverse cluster will contribute to further strengthen the profile of the University of Jena and will attract top-ranking students and investigators across the world.
The Microverse cluster comprises 3 research areas. The scientists in Jena want to explore increasingly complex microbial communities. To do this, they first look at how bacteria and fungi interact with each other and which molecules are produced depending on their conditions and neighbors. Christian Hertweg and his team want to establish what conditions lead to microbial balance and at the same time find new active compounds with therapeutic benefits. With the help of microfluidics, many different microbial partnerships can be investigated in a very short time. Miriam Rosenbaum cultivates and observes the microorganisms in tiny droplets. Balance in nature, especially in water, depends on microorganisms. Kirsten Küsel and Georg Pornet compare microbes in different habitats. Microorganisms exist in different conditions in lakes and groundwater. The scientists want to investigate common patterns and interaction mechanisms in these different environments. Human health depends on the microorganisms in our bodies. If this microverse becomes unbalanced, life-threatening infections such as sepsis can occur. Michael Bauer and his colleagues want to ensure that such diseases are detected and treated faster. To gain new insights, they are examining the microbiome of patients with sepsis. All of the microbes present in these patients. In order to study and alter very complex communities of microorganisms, new materials are needed. Ulrich Schubert and his colleagues are developing molecular containers, which can be used, for example, to deliver active compounds that are produced by microbes. But what was the human microbiome like before the discovery of antibiotics? Teeth from archaeological digs, thousands of years old, can help shed some light on this. Christina Warriner wants to examine the dental calculus, which could be interesting for understanding the microbial balance of humans in the present day. Plants specifically target microorganisms for survival. To protect themselves from diseases such as fungal infections, they even cultivate microbes that keep fungi away. Ian Baldwin's team wants to know what mechanisms are involved and how they can be transferred to the microbial balance of entire ecosystems. In order to better observe the tiny microorganisms and their interactions, new technologies are needed. Optical and photonic technologies, such as Raman spectroscopy, are used and adapted by Jürgen Popp and his team to the requirements of the life sciences. This will allow completely new insights into the Microverse. But only when all of this extensive data is brought together can comprehensive statements and models be derived. That is what Manja Marts and Gianni Panagiotou are doing. Their work enables more accurate predictions and targeted experiments to study complex microbial communities.
I firmly believe that only in a joint effort with scientists of different disciplines it will be possible to elucidate the fundamental principles of microbial balance and to use this knowledge to create beneficial impact for health, agriculture and environment.